Welcome everyone. I'm Richard Sinnott. I'm a manager in the chemistry department at SEPA with the remit for and an expertise in air quality measurement. And that's what we're here to discuss today, air quality monitoring at the Mossmorran complex. First things first, I'd like to reiterate my thanks to you all for taking the time to attend today. It's really important we understand your concerns. So now let's set some expectations. We will be discussing the air quality roles and responsibilities of Fife Council and SEPA. We'll do a dive into air quality standards and sources, and that will lead us nicely into what air quality monitoring has been done to date and the reasoning behind it. Finally, we'll open the session for any questions you may have. There are some things we won't cover today. We will not be covering operations on the site. We're not here to make apologies for the site, nor do we have expertise to go into too much detail about the processes at the complex. Right, responsibilities. As you can see from this slide, Fife Council are required to carry out air quality monitoring to ensure statutory objectives for air quality are not exceeded. More on those objectives later. In this case, the key contaminants of interest are nitrogen dioxide and particulate matter, the main source of which is likely to be road transport emissions, and we'll have more on that later too. With regards to SEPA's air quality responsibilities, well, in short, we regulate and monitor certain industrial activities that can generate air pollution. We also work with local authorities to monitor, manage and improve Scottish air quality. Another service we operate on behalf of the Scottish Government is the Airborne Hazard Emergency Response Service, which responds to major industrial fires and chemical releases which may impact on human health. This service does not cover monitoring for regulated activities. Both Fife Council and SEPA are members of the Mossmorran and Braefoot Bay Air Quality Review Group, which also includes the Institute of Occupational Medicine, NHS5, community councils and industry. Its purpose is to provide recommendations regarding the monitoring of air emissions arising from the Mossmorran complex by independently reviewing all air quality data available. Right, let's just get straight into those air quality basics. What are we all breathing in as we walk down a street in Scotland? This diagram from a scientific paper by Lenschow helps to identify the four contributors to air quality, that is continental, region and urban backgrounds, as well as traffic areas or point source loads. The Mossmorran complex is in quite a rural area, and we need to take that into account when we determine our monitoring locations. Although more people live in urban centres, when we deploy equipment there, we tend to predominantly pick up the urban background. Let's explore these four contributors in a bit more detail. Firstly, continental. Air quality and weather are intrinsically linked, and we'll use that as an example. Whenever we get those bitterly cold winds, it's when the wind originates from the north, and we get the colder air from places like Iceland. When it's a bit warmer, it's the wind blowing from the south, bringing the warm air from places like Spain or even Africa. As well as bringing warmer or colder temperatures, that air also brings some level of pollution. It could be volcanic emissions from Iceland or even Saharan dust from the African continent. There is a network of air quality sensors across the UK, and when we have a rise in the continental background, that is shown across all of the monitors in the network. Next up, we have regional. The regional background in Fife is driven by farming, amongst others. At certain times of the year, there'll be an increase in activity around crops, ploughing, spreading, harvesting, all of which can have impacts on air quality levels. Changes in the regional background may only show up in the monitors in that region. Urban background. Well, that's really driven by road transport. The monitoring we have done around the Mossmorran complex shows levels below those being experienced in the towns and cities of Scotland. Finally, we have what Lenschow refers to as traffic points, but we can think of these as point sources. For example, a particular farm, or it could be an industrial complex. Rises at any of these locations may only be seen in a local monitor. It's a combination of these sources that gives us our air quality, and changes at any of these can cause a rise or a fall in levels. Through the scientific analysis of ours and others' data, we have a good idea of the background levels in Mossmorran, which in turn helps us to identify when levels aren't as expected. We then need to do further work to assess what may be the source of that change. So that's what makes up our air quality levels in a broad sense. But what chemicals are we concerned about, and how do we compare them? So, what do we compare air quality levels with? Significant scientific research on the impacts of reduced air quality has been carried out, and that is to find air quality standards. Standards are concentrations of pollutants that are considered safe for humans and the environment. However, in Scotland, we use air quality objectives. Objectives are derived from the standards and are a compromise between what is desirable purely on health grounds and what is practical in terms of feasibility and costs. We compare against all available air quality objectives in our reports. In our reports, we also show levels against the Daily Air Quality Index, or DAQI. The DAQI system tells you about levels of air pollution and provides recommended actions and health advice for both at-risk individuals and the general population. The index is numbered 1 to 10 to provide detail about air quality levels in a simple way, similar to the sun or pollen index. Members of the public can view the air pollution forecast and near real-time air quality data at the website www.scottishairquality.scot. And this can help you determine whether you or your children are likely to be at risk from air pollution and what action you may wish to take to protect your health. This slide is produced by Public Health England, and it shows several sources of pollution and their contribution to the ambient concentration of certain species, i.e. particulate matter, volatile organic compounds, VOCs. Perhaps we'd better cover a bit about each pollutant first. Particulate matter is the term for a mixture of solid particles and liquid droplets found in the air. Some particles, such as dust, dirt, soot or smoke, are large enough or dark enough to be seen by the naked eye. Others are so small they can only be detected using a strong microscope. We often talk about PM10 and PM2.5, and the diagram on the page highlights the relative size of these fractions. In short, PM10 is any particle that is smaller than 10 microns, which, as you can see, means you could fit 5 particles across the width of a human hair. In the UK, most of the particulate matter pollution comes from residential and small-scale combustion. For example, wood-burning stoves are a significant contributor to particulate pollution. Other sources include road traffic, construction and farming. Of course, flaring is combustion, and therefore may also produce particulate matter, and that's why we have equipment in place to monitor this. Nitrogen dioxide. This is one of the group of gases known as oxides of nitrogen. Nitrogen dioxide primarily gets into the air from the burning of fuel and forms from the emissions from cars, lorries and buses, as well as power plants. Therefore, it's no surprise in the UK that the prevailing source is road and non-road transport. Again, with activities at the Mossmorran complex resulting in the burning of fuel, it's why we've monitored nitrogen dioxide at locations around the site. The PHE slide also mentions non-methane volatile organic compounds, or VOCs. The main source of outdoor levels is industrial processes, and this aligns with concerns you as a community have expressed. VOCs are emitted directly from many processes and include a variety of chemicals. Concentrations of many VOCs are consistently higher indoors than outdoors, as they're found in many household products. It's VOCs that give your perfume that pleasant odour, make those scented candles so relaxing, and even give those new carpets and furniture that nice fresh smell. When measuring VOCs, it can be either as total, i.e. the total level of all VOCs, or the level of specific VOCs, i.e. how much benzene there is. Currently, in the UK, we only have air quality objectives for the VOCs benzene and 1,3-butadiene. There is no limit on total VOCs. Sulfur dioxide and ammonia are also referred to in the PHE slide, but these are of less relevance to today's talk, and in the interest of time, we'll pass these by. Okay, we'll now run through the various activities we undertake. We won't go into too much detail, as all of the reports are available on the Mossmorran hubs on SEPA and 5 Council's website. The Council maintains a network of 58 diffusion tubes. These are the vertical bars on the map. They use an internal coating to measure the monthly average concentrations of nitrogen dioxide levels. In addition, 5 Council have installed 4 permanent roadside monitors to record real-time concentrations of nitrogen dioxide and particulate matter. These are the asterisk symbols on the map. The Council have also invested in newly developed air quality sensors that can be attached to a lamppost where it is difficult to locate roadside monitors. In the event that statutory objectives are at risk of being exceeded, the Council should declare a management area and draw up an action plan. There are currently 2 management areas in Fife where people are living close to busy roads. One is in Cooper and the other is in Dunfermline. As you can see from these graphs, levels of nitrogen dioxide and particulate matters at these sites are falling, and this year both management areas have been partially revoked. For SEPA monitoring, once concerns around flaring increased in 2017, we were quick to provide monitoring which would give useful information. Concerns were raised about black smoke and prolonged flaring, and as we've touched on throughout this presentation, flare is a source of combustion, and combustion produces particulate matter. To monitor this, during responses, SEPA specialists provided downwind monitoring to assess levels of particulates. This did not identify any elevation, and that also suggests other products of combustion would not be present. As concerns continued around flaring at the site, SEPA defined a 3-month monitoring strategy to start early in 2019. A monitoring trailer measured the pollutants nitrogen dioxide, sulfur dioxide, carbon monoxide, and particulate matter to the northeast of the complex. We also deployed diffusion tubes at 4 locations. These tubes were used to determine the levels of nitrogen dioxide and VOCs. Whilst deployed, there were 3 flaring episodes and no breaches of any air quality objectives. All measurements were in the low band for the daily air quality index, except for PM10 and PM2.5, which were in the moderate category on one day. This wasn't during a flaring episode, but it coincided with a period of elevated particulate matter across Scotland. At the end of the campaign, monitoring equipment was returned as planned and utilised for other regulatory work across Scotland. However, following further flaring events, the previous equipment, alongside 3 other particulate monitors, was returned to the Mossmorran area late summer 2019 and remains in place today. Our equipment is positioned in locations that gives us the best balance between telling people what air quality levels are like, where they are, but also to help us identify whether the Mossmorran complex could be causing an increase. As is seen in this diagram, the prevailing or most common wind direction in this area is wind blowing from the southwest. Therefore, the best place to locate equipment is downwind, i.e. to the northeast of the site, and also upwind to the southwest of the site. At all of our monitoring sites, there continues to be no breaches of the air quality objectives, and results can be considered low when compared against the DACI bandings. A further diffusion tube study was also carried out between October 2019 and February 2020, and this showed that levels of benzene and 1,3-butadiene remained well below their air quality objectives. Other VOCs do not have objectives, but results did not indicate a rise above background. Talking of background, some of the monitoring coincided with a prolonged shutdown at the site, but this allowed us to gather some useful background information. We've not carried out any real-time measurement of VOC monitoring, and this is something that we have heard from the community and received in the Irish EPA recommendations. To finish, we thought it'd be worth reviewing the technology that is available for monitoring. Here, we've plotted various technologies on a graph showing their approximate cost against the quality of their data. When we talk about quality, we really mean how much you can trust the data to give you a true picture of what the air pollution levels are. We'll start in the bottom corner with home sensors. These are usually less than £100 and are generally meant for measuring indoor air quality. As you can see, SEPA view the quality of the data produced by these sensors as very low. Often, if you have 2 sensors side by side, you'll get completely different results. Home sensors can perhaps tell you if things are going up or down, but they do not give you a figure you could reliably compare against air quality objectives or the DACI bands. You can achieve good spatial coverage, however, all that data is meaningless if it's of poor quality. The next stage of equipment is indicative sensors. These usually cost upwards of £3,000. Inside, some of the technology isn't too different from the home sensors above. However, a large amount of research is being carried out on these, and that ensures a high quality of result. Correction calculations help to account for things like changes in the weather, and the sensors undergo regular quality checks, often by independent professionals. There are sensors for multiple compounds, providing real-time data. Usually they're attached to and powered by lampposts, and 5 Council have already referred to their use of these sensors at various locations. This equipment still cannot be used to compare against air quality objectives, but it does give us an indication of what air pollution levels are like. Next up, we have indicative monitors. These are often used in industry. Data is real-time, and the technology and quality are vastly improved. With that comes an increased cost of upwards of £10,000. With this cost, we need to ensure we are locating these monitors in the most scientifically valid locations. These need to be secure from vandalism and contamination and with access to power. Power can be a big issue in a rural area. Sometimes, to get a good location with power, we're closer to a building or trees than we would like. There are indicative monitors for several species, including particulate matter, some of which we've currently deployed at the Mossmorran complex. Even with these monitors, it's difficult to compare accurately against air quality objectives. In the past, we've also used diffusion tubes. These are placed around the site and left for 2 weeks before being sent to an external laboratory. This gives us accurate concentrations for a range of VOCs as an average over the 2-week period. It's a common tool used by local authorities across Scotland. Results can be compared against air quality objectives. However, laboratory analysis costs a significant amount of money, reducing the length of time the tubes can be deployed for and the number of locations they can be deployed at. We also understand that the averages of a fortnight do not sufficiently answer your concerns, even if the values are below air quality objectives. Finally, at the high end of both scales, we have reference method analyzers. These come at high costs, generally closer to £20,000 per analyzer, and have higher running costs. They also produce real-time data, have the highest data quality, and can be compared against air quality objectives. These units need to be located in special enclosures, and as such have a large footprint and require significant installation and additional infrastructure, which makes finding scientifically robust sites in rural areas difficult. Okay, that's a quick run through the various equipment types available, and each investigation we do requires different tools or combinations of tools. We're often asked what our plans for air quality monitoring are going forward. We currently use a mixture of indicative monitors and reference method analyzers and produce regular reports. SEPA's studies show that there is no identifiable effect on air quality from the activities at Mossmorran, either from flaring or ongoing operation, and this has been confirmed by the Mossmorran and Brayfoot Bay Independent Air Quality Review Group. However, there remains community concerns. To that end, we continue to review complaints and various social media channels to assess what the main concerns are, and as has been mentioned, the Irish EPA have reviewed our approach to regulation at the site. Plus, of course, we have these 4 community sessions to understand some more of your concerns. Okay, to summarise, significant monitoring has been undertaken to date in the surrounding area. This has not identified any issues that can be linked to the sites, and our approach has been verified by the Mossmorran and Brayfoot Bay Independent Air Quality Review Group. However, SEPA remain committed to ensuring the provision of air quality information. We'll now open the floor for further discussion. We'll be using some live polls to help stimulate the discussion, and once again, thank you for listening.